Okay.
So here we have a 2-cell multicellular system. Each cell is composed of 4 proteins, so you can see that there are 4 identical sections on each of these PCBs, and they communicate with each other to coordinate a distributed task management strategy. So in this demonstration, we have 3 tasks running. They flash the LEDs at different colors. So we have a blue task, a red task, and a green task. And this system will try to keep these tasks alive even as you kill proteins. In addition to the tasks, each cell has what's called some macromolecular machinery, which flashes the LED like a heartbeat. And this is kind of the brain of the cell. So it monitors the other proteins and will do reconfiguration if it's necessary in the event of failures. So what I can show you now is I will kill 2 of the proteins. I'm going to kill the red one and the green one, and then we'll see them come alive again as the system reconfigures. So those tasks will move on to other proteins which are currently dormant. All right, so if we physically kill the power to this one and to this one, yeah, okay, killed the wrong protein there. That's okay. We'll still see them come back alive again. We're just waiting for the green one to show up now.
And on your screen there is the programming. The big blocks are the programming.
So yeah, at the bottom here, this is health check data. And over here, we can see which tasks are running in the system right now. So we see 1s and 2s and 3s, which mean that all the proteins are currently running. And we can see that they're all back again over here. So what happens now is, in addition, if we bring these back alive again somehow, the short circuit resolves itself or whatever, the system will realize that those proteins have become functional again, and it will use them as backup. So it'll reprogram them with one of the tasks that's already running and just keep them in reserve. So we can try this one more time. I'll kill some proteins and then we should see them come alive again. Okay, let's go for this red one and this blue one. All right, and now we'll watch the system react. So if we look up here, we'll see that, okay, now only 1 and 2 are apparently running. And then new numbers appear as the tasks show up again. So let's just watch them reappear. At the moment there's programming happening down here. Okay, red is back. Now we're just waiting for blue. And blue is back again as well. All right, now the final thing to show is that this macromolecular machinery may appear to be a single point of failure on the cell, but it's not. It's also just a protein, so if we kill it, it will also just reappear on a different protein. So I'm going to kill this one over here. All right, it's dead now. The cell notices it's dead, and this protein is now given up on the job it was doing, and it is going to become the new macromolecular machinery of the cell. And that's happening, in fact, by this neighboring cell reprogramming this cell. So normally programming just happens within the cell itself, but in this case it happens between cells in order to bring the cell back to life. And we should see this come up again. It's back. And at the moment there's 2 green ones. Does that resolve itself? No. It did resolve itself. There we go. So let's see, where did the blue one go now? The blue one became the macromolecular machinery, so that's got to turn back into a blue over here. It's busy programming. And there it's back again. And the system is back to being stable with 1 macromolecular machinery per cell.
Excellent.